Hello everyone. This lesson is for 11AB Core Math. Today's topic is real numbers and their properties. Numbers are always related to our daily lives, right? And what are the real numbers? Most students we answer as all the numbers on the number lines. Then we're gonna classify all the number on the number lines. Okay. Real numbers, we'll break it down two kinds, or can say there are two kinds of real numbers. One is rational number and irrational number. Then I will write down for what is a rational number. Rational number will have three types of number. First, integer numbers. Second, whole numbers. And last one is national numbers. So, rational numbers, what are the rational numbers? They are the set of the number which can be written in the fraction form or ratio. Okay, for example here, the set of fraction like A over B such that A and B belong to integers, which is B not equal to 0. I represent integer numbers. What are the integer numbers? Integer number have three kinds. One is 0. And second, 1, 2, 3, and so on to plus infinity. And then third one, -1, from -1, -2, and so on to negative infinities. Okay. Then we know now integers, I represent integer that have three kinds here, right? So then you can see A, B have to be integer number, for example, and form it like at the fraction form. So we have, for example, I have 2 over 5, okay, or like even negative, maybe 6 over 7, or we can write it like a repeating decimal, like a 0.3 and half bar. Sometimes we write it down 0.333 and like that. Okay, like for example 1.25 or 0.4, something like this. Okay, so I will write this integer a little bit lower. Integer number. Okay, so what is a whole number? What is whole number? Whole number start from 0, 1, 2, 3, 4, and so on to plus infinity. How we remember whole numbers? Whole numbers, you can say whole like a whole, right? Whole like have the shape like a one open dot, something like this. So you can remember whole, you start from 0. Okay, and next, national numbers, or sometimes we call counting number. We will start from 1, 2, 3, and so on, 4, 2 plus infinity. For example, counting numbers or natural numbers, the words already tell us, right? For example, like in this class, I will ask, how many students in this class? Then you're gonna start to count it. You do 1, 2, 3, and 4, and so on, right? We did not start from 0 or -1, -2. Okay, so then from all this one, can I go back to rational number? Because from here rational number, there are within rational number there are two kinds of decimals. One is a terminal decimal, one is the terminating decimal, sorry, and the second one is a repeating decimal. Okay, I will write down here. They have two kinds of decimal. For example, let me give the space to edit this one. First one is terminating decimal, and the other called repeating decimal. For example, what is the terminating decimal? Like this example I get to you, 1.25, 0.4, or like a 6.39 something, right? Or maybe 2.5 something. Mean when you do the division, for example, like a 0.4, we can write as a 4/10, right? And then we do long division, our remainder equal to 0, like a 4 divided by 10. Okay, so we have 4, and then our remainder is a 0. So this kind of decimal we call terminating decimal. But for repeating decimal, like this example, 0.3, or we write down 0.3333 because the remainder not equal to, remainder doesn't equal to 0. Okay, so now this rational numbers have two kinds of decimal, terminating decimal and repeating decimal. Okay, so from this all kind number is on the board. I can write down in the diagram. This can help us to see easily. Okay, for example here, natural number or counting numbers is subset of whole numbers. So I can write the diagram down here. Okay, this is a subset of whole number. And then natural numbers or counting numbers and whole numbers are subset of integer numbers. So I can write the diagram also a subset of this one. And the final, natural number or counting numbers, whole numbers, and integer numbers are subset of rational numbers. I have to cover this one. And this will cover all in. Okay. So this is this one. So this one is rational. Then after then we come to see the irrational number. Okay, because not enough space, so I may write down here, so you can see what it means. So say if I have real number, there are two kinds of real number. One is rational, the other is irrational. irrational numbers. So we already know what are the rational numbers from this diagram, right? So now irrational numbers will be opposite with the rational numbers. Just say this irrational number can be in the fraction form. Okay, but this one for example, is mostly like square root and the number in the palm number, square root 2, square root 3, square root 5, something like this, and including pi, okay, like a pi, including pi. For example, if I have pi plus maybe 8, this one is a rational or irrational? It must be irrational, correct? Because I have pi. So this one have to be irrational numbers. Okay. So because all these one, when you write in the decimal, when you convert, you use calculator, all this number gonna have the number keep going without repeating. Like a pi equal to 3.14159265 and so on, and keep going without repeating number. Okay, so this is about real numbers. Okay, for the two kind of real number, rational and irrational. So next one, I would like to let everyone to see the example by using all the definition on the diagram here. Okay, so the example C, list the number this kind and graph the number on a number line. Then A, the whole number less than 6. Okay, so the whole number less than 6. Let's see this. So we draw a number line here, right? Whole number, you can see whole number is what? Start from 0. Whole number start from 0, 2, 3, 4, 5, and so on. So less than 6. For example, here we are 0. I start from here 0, 1, 2, 3, 4, 5, and 6 here. So then you will label the sign on less than 6. Doesn't have equals, say equal to 6, right? So at the number 6 you have to open them. And number 5 have to be back up, 4 back up, 3 also, 2, 1. Equal 0 or not? Yes, because definition here. So you have back up. Then you can write the set of notations. So you write down the set of solutions will be 0, 1, 2, 3, 4, and 5. No 6, okay, because 6 doesn't include. 6 is not part of this solution. 6 is not a part of this solution. Now we try one more. B. If the integer number is the integer number greater than, try greater than greater than or equal to try any number, maybe 3, right? Okay. So the integer number greater than or equal to 3. Integer number come back to our definition, 3 kinds, 0, 1, 2, 3, and to the left side, -1, -2. Okay, now we draw a number line. Integer number greater than, so 0. I start with 1, 2, 3, This side going to be -1, -2, right? So this is negative, this is minus 2. So then see, integer number greater than or equal to 3. Equal to 3, right? So must be equal, right? So you like the vector. Greater than maybe less or 3. Okay. Then greater than or equal to 3, vector here. Because this is an integer number, so you're gonna write down 4 vector, 5 vector also. But because greater than, then that means they will keep going until plus infinity, but they will use this sign, the 3 dot, this represent and so on. Okay, now you can write the solution set gonna be 3, 4, 5, and dot, dot. Okay. Okay, now we try. Any questions? Okay, now go next one. Question C. The real number. The real number maybe say greater than -4 maybe. Okay. So the real number greater than -4, then we draw a number line. Okay. Greater than -4. For example, our 0 here, 1 here, and this one plus 3, and this one -1, -2, -3, -4. Okay. So real number, don't forget real number. Real number means include everything on our here, including irrational also, but I erased already. Okay, don't forget this one, including irrational number. This is another box, right? So we have to count. So that include all the numbers, a number line. So when we represent greater than -4, greater than -4 not doesn't have equal, right? So the -4 you must be over it. And greater than have to be left hand side or right hand side? Right hand side, right? Because the number is increasing. So you're gonna use the draw one line with the arrow. Okay, so this represent real number greater than -4. Then our solution set, you can write it down become say open -4 and 2 plus infinity. Okay, or you can write down same meaning. Okay, you can write down here. So x less than infinity or greater than -4. We don't have equal sign underneath because they did not say equal. So this is gonna be open interval. Okay, this is about the real numbers concepts. Okay. By the way, can I ask you in here rational? If I have, for example, I have 9. You think 9 this is a rational, irrational, or integer, or whole number, or counting number? 9 can be many, right? Can be rationals, can be integers, can be whole number, and also can be counting number. How about if square root 25? 25, if you take the root, gonna be what? 5, right? So same thing, 5 gonna be can be rational, can be integer, can be whole number, can be counting numbers. Okay, you know, like number 9, we just finished. Because 9, we can write it down in a fraction form, like 9/1. So it's like a fraction concept already. So this called to be rational. How about 0? 0 can be rational or irrational? 0 can be rational because 0 can be divided by 1 also. Okay, so 0 can be rational, can be integers, can be whole number. That's all. Okay, so this idea of real numbers. think that's all for today for our lessons. So, by the way, I will provide you the handouts and have the exercise that you practice for this lesson. Actually, this lesson is for reviewing, and I believe all of you used to learn in previous years already, so we may not take too long for this one. Okay, so and if you have any questions, you can ask me. I would like to have your, if possible, okay. I want to have, I wish to have your email address, or we can set a line group. But so far, at right now, you contact to the school websites in the Google Classroom. So I will post all the handout and information that you know so far at this time. Okay, pass by the school website. Okay, I think that's all for today. I hope everyone like it or understand the lesson today. Hope to see you next time. Okay, bye bye.